This short lesson is going to examine numbers, digits, and place value. So the first thing I want you to do is think of the largest number you can. Now hopefully you should have said there actually is no largest number, because any number you could give me as potentially the largest, I could always add 1 to it and therefore make it larger. And now I want you to think of how many different symbols are there that we use to make up our numbers. Now hopefully in this case you should have said 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So once we get past 9, it's not like we use this symbol for the number 10. No, we go back and we use a 1 and a 0 to make the number 10. And it's not like for number 24, that's the symbol. We use a 2 and a 4. So we have an infinite number of numbers, but we only have 10 symbols to make up those numbers. So a number is just a quantity, but a digit is the single symbol we use to make numbers. Or in other words, digits are the symbols we use to make numbers, if you want to look at it plural. So now what I want you to do is see if you can change this number 4, pretend you have it written on your paper, or actually write it on your paper, without erasing it. In other words, I don't want you to just pick up an eraser, erase it, and write the number 3. That's not what I mean. I want you to see if you can change that without erasing it. Well, one thing you could have done was this. This 4, the quantity of 4, has now become the quantity 41. Because this 4 is still the same digit, but it's now in a different place, so what it's really representing is 40, and the 1 is representing 1 for a total of 40 plus 1 equaling 41. So that brings us to place value, which is the value of a digit based on its position. Value of a digit based on its position. Let's look at another example. In this example, we have the quantity, or the number 372, and we have 3 different digits used to represent that quantity. We have a 3, a 7, and a 2. But the 3 is not really a 3, it's really representing 300 because it's in the hundreds place. The 7 is representing 70, and the 2 is representing 2 ones, or in other words, 2. So 300 plus 70 plus 2 make our 372. So let's look at another example. I'm going to look at more place values. So I just wrote out the digits 1, 2, 3, 4, 5, 6, and 7. Right. So we have a 7 in the ones, a 6 in the tens, a 5 in the hundreds, and then this is the thousands, 10,000s, 100,000s, and millions place. So our number is, so millions, I'm going to abbreviate, 100, thousands, and thou for thousands, 10,000s, just thousands, hundreds, tens, and ones. Right? And so notice, as we move from right to left, each time we go up a place value, we're essentially multiplying by 10. 1 times 10 is 10, 10 times 10 is 100, 100 times 10 is 1,000. And so that's how we move from one place value to the next as we move from right to left. Now if we want to go from left to right, we divide by 10. So let's have you try one. See if you can identify the place value of each digit. Well, we have 3 in the thousands, 5 in the hundreds, 6 in the tens, and 8 in the ones. Okay, and one other thing that I should mention in regard to this topic is when you have a number, say 462, written like this, that is standard notation, and that's what you're used to seeing in everyday life. But there is also a notation called expanded notation, and what that does is it identifies the place value of each digit and writes them all as a sum. So in this case it would be 4 hundreds plus 6 tens plus 2 ones. And that is expanded notation. And that concludes this short lesson.